So resolution and grid cell size are critically important when it comes to 3D geological modeling. In vein modeling, scale refers to how vein dimensions such as length and thickness change across different observation levels, from outcrop to mine scale to regional scale. And it also reflects how modeling software handles scale, different data types like drill hole samples and modeling parameters such as triangle size, or snap intolerance. All of this influences model realism, from small mineralized shoots to large structural systems. So in practice, this means managing multi-scale detail from broad fault system down to individual ore shoots while maintaining consistency in geometry and grade distribution. In K-Mine, vein models are built using drill hole data, surface information, and structural controls such as fault surfaces. This allows us to bridge scales, linking discrete point data and continuous geological surfaces. In implicit vein modeling, scale becomes essentially important. Narrow veins represent a small-scale challenge, while large faults operate at a large scale. Mathematical interpolation methods such as radial basis functions or kriging define veins as isosurfaces, while structural data constrains geometry. Often, the most realistic results come from hybrid methods combining implicit and explicit modeling. And it's also important to note that continuity is highly scale dependent. At a large scale, structural continuity may extend for kilometers. Within that structure, vein continuity may persist only for tens of meters. But because gold is often concentrated in narrow veins, great continuity can appear low globally but strong locally. And for this reason, continuity should be discussed at multiple scales. When we move into mineral resource estimation, scale again plays a defining role. The scoping study is generally based on inferred resource with wide drill spacing and global continuity assessment. A pre-feasibility study requires a higher confidence supported by closer drill spacing and indicated to measured resources. At this stage, continuity can be assessed at a local scale, while inferred resources are excluded from economics. By the feasibility stage, modeling reaches maximum detail. Scale-related challenges often stem from choosing the wrong level of detail. Using mismatched data scales leads to misinterpretation. There's always a detailed trade-off between resolution and coverage. Scale-related errors directly affect model reliability and risk, and integrating data across multiple scales remains a key challenge. High-resolution data increases cost, often with diminishing returns. Project teams must balance technical details with practical constraint. And modern software like K-Mine supports scale decisions, balancing resolution, coverage, and reliability.